Hey guys, Dibs here. Let's go over how to find a relationship between two variables and do a linear regression. Let's go. Our sample data is of cricket chirps collected during a series of summer nights. The rate at which crickets were chirping, temperature, wind speed, and humidity were recorded. First, we need to phrase our hypothesis correctly. Here's an example. The rate at which crickets chirp will be related to temperature. Notice we're highlighting just two variables, even though our data contains a lot more. First, make a new sheet within your Google Sheet. This keeps our raw data organized and untouched while allowing us to do our analysis on a clean page. Let's name the sheet something we can easily remember, and let's also write our hypothesis on the page for reference. Let's add some labels at the top of our page for both variables we're looking for a relationship between, cricket chirps and temperature. Make sure that your independent variable is the first column and the dependent variable is in the second. Google Sheets will always put the first column on the x-axis. For this example, we expect cricket chirps to depend on temperature. So we'll put temperature on our x-axis and cricket chirps on the y-axis. Then let's copy and paste the data from our raw data sheet into our analysis sheet. Use Control-C to copy and Control-Shift-V to paste. This way, we don't carry over any of the formatting from the other sheet. Next, highlight all of the data, including the labels at the top. Click Insert Chart or click the Insert Chart icon on the toolbar. You should now have a scatter plot by default. If not, simply select Scatter Plot from the list. Now that our plot is made, let's get serious. Consider changing the size and color of your data points if there's a lot of overlap. Ours are fine, so we'll move on. Then we can add a trend line to see if there's a relationship between these variables. Next, let's do some statistical analysis. Check the R-squared box. You can now see our trend line has an R-squared value. This R-squared value is a number between 0 and 1 that indicates to us how well the trend line represents the data. A value of 1 means that our data is perfectly represented by the trend line, and a value of 0 means that there's absolutely no relationship. Generally, we accept an R-squared value that is greater than 0.9 to be a meaningful relationship between the two variables. Now that we're done with our analysis, let's get into some of the formatting that we need to do. First, click on the Customize tab and open up the Chart Style options. Select a font and a background color that match your presentation medium. For example, our papers follow APA formatting and are written using Times New Roman font. You can select the serif font to match. For PowerPoint presentations, it's important to match the background color of your graph so it doesn't look like a sticker on the slide. You can match the color directly, like this, for a more professional look. If your slide has a more complicated background, such as an image or a gradient, you can select a transparent background for your graph and it'll fit in great. Now, let's make sure our axes and graph are properly labeled. Click on the Chart Axes and Titles section. Then, from the pull-down menu, select Chart Title and delete it. We'll be adding the chart title in directly on our paper, PowerPoint, or poster board. Here's an example. Then, click on the vertical axes labels and horizontal axes labels and ensure that they're properly written. Also, make sure they have the appropriate units in parentheses if applicable. Now let's talk about bias in our graph based on the scale of the axes. By default, Google will always scale the y-axis from 0 to the maximum value you have in your dataset, and the x-axis from the lowest to highest value in your dataset. You can click on the horizontal axes or vertical axes sections and adjust the minimums and maximums for each axis. For this example, I might consider setting the minimum temperature to 32 degrees, the freezing point of water, in order to give our x-axis a more meaningful scale. And now we're done. There's certainly more we can do with Google Sheets, but this should be enough to get you started with linear regression analysis. For more guides specific to high school science research, make sure to subscribe. In the meantime, stay curious, cite your sources, and may your data always be statistically significant. Catch you in the next one.